बिस्मिल्लाहिर्रहमानिर्रहीम। तो आज का हमारा जो टॉपिक है इन क्वांटम मैकेनिक्स दैट इज Schrodinger equation for hydrogen atom. So our topic is Schrodinger equation for hydrogen atom. Schrodinger equation for hydrogen atom. For hydrogen atom. Hydrogen atom. So we have today's topic that is Schrodinger equation for hydrogen atom. इसी के साथ we also cover up other part of this your syllabus that is radial and angular wave functions. Radial and angular, ये बहुत ही important topic है, angular wave functions. Radial and angular wave functions. So these are our topics for the day. That is Schrodinger wave equation for hydrogen atom and what do you mean by the radial and angular wave functions and what is their importance. जैसे मैंने पहले भी कहा कि जो क्वांटम मैकेनिक्स का जो आपका सिलेबस है इट्स मोर ऑफ अ मैथमेटिकल और बहुत वास्ट है, लेकिन बीएससी लेवल पे जो हम ट्राई कर रहे हैं एंड यू नो एज पर द सिलेबस. So we'll not go deep into this. We'll try to obtain the basics out of this so that we can actually compete in the exams or any objective type exam or any, the future exams. Okay. So Schrodinger equation for hydrogen atom. Now for that हमने जो अभी तक जो पढ़ी थी Schrodinger equation that was हमने equation पढ़ी थी that is del by del x square of wave function psi del square psi plus del square psi by del y square plus del square psi by del z square plus 8 pi square m by h square e minus v into psi that is equivalent to 0. तो ये हमने अभी तक पढ़ा था in our syllabus. So this is your called as the Schrodinger equation, time independent equation. Now और हमने I am repeating this again and again that this equation is valid for simple systems जहाँ पे एक इलेक्ट्रॉन हो like hydrogen atom or lithium positive, helium positive, lithium dipositive and so on. तो अब now what about Schrodinger equation for hydrogen atom? That means हमारे पास क्या है? In the hydrogen atom we have a nucleus and we have a single electron that is located somewhere around this nucleus. So we have a single electron. Now the Schrodinger equation for hydrogen atom, इसको understand करने के लिए तो हमने कहा था कि that wave function is first of all हम देखेंगे wave function कैसे vary हो रही है along the x direction, how it varies along the z direction, y direction and how it varies with respect to z direction. So then we have drawn the a Cartesian coordinate system. इसके लिए हमने एक coordinate system बनाया था that's called a Cartesian coordinate system. This is our Cartesian coordinate system. तो इसको हम express करते थे in the Cartesian coordinate system. So this is your Cartesian coordinate system. जहाँ पे हम understand करने के लिए system को understand करने के लिए we use a Cartesian coordinate system. Coordinate system. So our variables are so our wave function depends on variable. This is your x, this is your z axis and this is your y axis. and फिर हमने कहा था कि let us say it moves along the x-axis, so then how the wave function varies with respect to x. Likely, if it moves along the z, then how the wave function varies with respect to z. Likely, if we are dealing with the electronic wave along the y-axis, so we say double differential of wave function with respect to the y coordinate. Now, आज की क्लास में we are interested in the in the hydrogen atom. That means we want to know the energy of the electron with respect to the nucleus. ये बहुत important है. देखो एक चीज होती है कि nucleus atom moves itself. That means when we say atom moves itself, that means it is basically the translation motion. That means both electron and the nucleus is moving along the x-axis or along the z-axis or along the y-axis. When we say electron, when we are trying to understand the energy of electron, that means what we are doing, we are assuming that the atom is not moving. We say that we are neglecting the translation motion. So when we say Schrodinger equation for hydrogen atom, when we try to understand this, so what we are assuming that number one, that we are actually neglecting, or we are not taking into consideration, we are neglecting the translational motion of atom. So we are interested that how the energy of electron varies with respect to the nucleus, or where this electron can be found around the nucleus. So we are interested in that. In order to understand that, we'll assume that our nucleus is present here at the origin of the coordinate system. Let us say it is point O, so this is our nucleus, and our electron is located somewhere here, that is A. And this distance let us say this is called as R. So it's located from the nucleus at a distance of this R. So this is the distance R. Now उसके बाद, so this is the distance of electron from the nucleus. उसके बाद हम क्या कर लेते हैं, we'll draw a projection here. तो projection हम ऐसे ड्रा करेंगे इसको. So we'll draw a projection. So this is a projection of this OA. So this is the projection of OA. अब ये जो projection of OA, let us say it makes an angle with the x-axis. That angle is called as phi. So this is, it makes an angle phi. And this radial distance, let us say it makes an angle. So this is the projection of the radial distance, projection of this. So it makes an angle of phi with the x-axis. And this radial distance, it makes an angle of theta with the z-axis. So once we have done this, now, so what we say, now we want to understand that we want to say why is actually what is, our aim is to know the energy and the distribution of electron around this nucleus. So what we have done, we have drawn the projection here, projection of this radial distance, and then let us say it makes an angle phi here, it makes an angle theta here. So what we'll do in the point number 2, we have to convert linear coordinates, that is x, y and z, into polar coordinates. ये जो theta और phi है, these are called coordinates, polar coordinates. So by drawing this projection and this distance and this this angle, so what we will do now, we will convert the linear coordinates, जो earlier case था x, y, z, into the polar coordinates. आप यहाँ पे मैथमेटिक्स से इसको आराम से सॉल्व कर सकते हो. आप you can also try the books also, because I will not deal with that deep mathematics here. So you can easily calculate that. For example, साथ इस example ले लेते हैं हम यहाँ पे. Now this is your z-axis, fine. If we, let us say you draw here. So this is, you take the cos of theta here. So cos of theta is that's base by this hypotenuse r. That means z will come out to be equivalent to, from this triangle, z is equivalent to r cos theta. So we have converted that z into r cos theta. Now this cos theta is now the polar coordinate. Z was the linear coordinate. Now we have converted z into r cos theta. Likely you can convert. You can obtain x as r sin theta cos phi, and you can also convert y into r sin theta, r sin theta sin phi. So this way you obtain the polar coordinates now. So you convert the linear into the polar coordinates. So overall, then you take these values and you utilize those values here in this equation. So you will get the Schrodinger equation now in the form of the polar coordinates. So that I will not going to deal with that. Now what is the importance now? I want to say that the wave function, हमें हमारा important क्या है, यहाँ से जो wave function निकली उसको understand करना, उसके values obtain करना, so that we can actually see where is that wave function, where is the electron located, where is the electronic wave located around the nucleus, what is the probability of finding that wave around the nucleus, and what is the energy of that electronic wave. So overall what we say that now our wave function, in earlier cases that wave function, it depends on the coordinates x, y and z. Now in this polar coordinate system we say that the wave function, it depends on, it's a function of radial distance, that's r, and then it's a function of theta, that is the angle between the z-axis and this radial distance, and also it's a function of phi. तो wave function का value depend करता है r radial it's a radial distance, that's OA. It depends on the phi and theta. That means ये जो wave function हमारे पास है अब now that wave function is basically product of two terms. So that wave function is basically, so I can write down that this wave function is basically, it's a product of two parts. One is, ये तो हो गया radial part, and these two are called angular parts. So it's a product of this, and it's a product of theta and phi. So this wave function, in case of hydrogen atom, it's basically product of radial wave function, and this is called angular wave function. So it's basically, यहाँ से हम directly इसको, what we do is that हम कहते हैं कि at what distance it is located from this point O. So this is simply called the radial radius, it's called the radial wave function. यहाँ पे at what angle it is located with respect to x, and at what angle it is located at z. That means what is the orientation. So यहाँ से हम क्या करते हैं basically, so this wave function gives us the orientation or the shape of that electronic wave which is present around the nucleus. So basically now the wave function is a product of radial wave function, and this is your angular wave function. So this wave function is a function of a radial wave function and angular wave function. इसको आप books में इस तरह से भी देखोगे that our wave function, which has been expressed in terms of polar coordinates, that is basically equivalent to, आप books में ऐसे देखोगे इसका, it's called a radial function, it's a radial, or it's called a radial part, and theta, आप इस तरह से इसको देख सकते हो books में, into it actually means the same thing. So this is the radial function and this is called angular function, or this is the angular part and this is the radial part. So there are two wave functions now. The overall wave function depends on the radial part and the angular part. So what actually it means, angular part, radial part का क्या meaning है? Radial simply means at what distance that electron is located from the nucleus. These angular parts give us with respect to the angle, at what angle they are located. If we are considering this Cartesian coordinate system, that means how is that oriented around the nucleus. So that means it gives us concept of the orbitals, basically this angular part. So we should say that angular wave function gives us the orientation of orbital, orientation of electronic cloud, or orientation of electronic function. It gives us the concept of orientation, or it gives us concept of orbital. While as this radial wave function, it gives us the concept of simple the distance from the nucleus, a radius of the electronic cloud from the nucleus. It will use the distance from the nucleus. Okay. Now उसके बाद, when we solve the Schrodinger equation, we need certain constants, and it has been observed that it has been after solution that the constants are basically the quantum numbers. So we should say, for the solution of Schrodinger wave equation, for solving Schrodinger equation, so जैसे mathematics में equations में we use the constant. Same is the case here. Certain constants are known. Certain constants. And those constants are basically here, they are called as quantum numbers. जो हम 11-12 में पढ़ते थे, quantum numbers. जैसे n principal quantum number, L is mutual quantum number, M magnetic quantum number. Spin quantum number has nothing to do with the Schrodinger equation, ठीक? And now, जो आपका radial wave function है, that is R, that's the radial wave function. So for this, it depends on the quantum number n, that is the principal quantum number. So a radial wave function depends on the principal quantum number, and it depends on the azimuthal quantum number. उनको हम आगे डिस्कस करेंगे, this principal quantum number and azimuthal quantum number. Likely जो आपके पास जो angular wave function है, that is this one, इसको हमने ऐसे भी लिखा था. It depends on quantum numbers like azimuthal quantum number and magnetic quantum number. And while as the wave function, that is the phi, so it depends on only magnetic quantum number. ये बहुत important information है, that the wave function depends on the radial part of the wave function depends on principal quantum number and magnetic quantum number. This is azimuthal quantum number. And the radial wave functions, that is this and this. So one radial function, that is theta, it depends on azimuthal quantum number and magnetic quantum number, while as the other part of the angular wave function, that is phi, sorry, this is phi, so it depends on the magnetic quantum number. तो इसलिए आप बुक्स में इस तरह से भी देखोगे that overall the wave function in case of hydrogen atom, that it's like shown like this, r, theta and psi. It is basically equivalent to r. Since it depends on n and l, you will see that it is written in the bracket n and l like this. Likely depends on theta, and then you have L and M. So in the bracket you have here written as theta, and then it is the product of, since it depends on magnetic quantum number, You can write that as a subscript, then psi. So this is your basically the wave function which is obtained after solving the Schrodinger wave equation for the hydrogen atom, where we assume that or we do not take into account the translation motion. So what we do is that wave function obtained, it depends on the radial part, and this is called the angular part, and this is also called the spherical harmonics. कुछ books में आप ये भी देख सकोगे. So this is the radial part. A radial part, it just depends, gives us the it tells us the distance of electron from the nucleus, or I can say that it gives us the distribution of electronic wave from the nucleus, while as this radial angular part of the wave function, it gives us the shape of the orbital. ये बहुत important है. So it gives us the shape of the orbital, this angular part, or it tells us that at what is the orientation of that electronic cloud, or what is the orientation of that wave function with respect to the x, y, and z coordinates in the 3 dimensions. So this gives us the concept of orbital. This gives us the distance of electronic cloud from the nucleus, or distance of wave function from the nucleus. So this radial wave function, it depends on principal quantum number and azimuthal quantum number, while as the angular wave functions, they depend on azimuthal quantum number, magnetic quantum number, and the magnetic quantum number. So this is all about the basics of the radial and angular wave functions in case of hydrogen atom. So where we convert the linear coordinates into the spherical coordinates or angular coordinates, and then we get the wave function, which is basically product of radial and angular part, and then when we solve this, we know that it requires some, it can be solved with the help of some constants, and those constants are basically the quantum numbers which are used to specify the electron in the atom. So for the radial part, it depends on the quantum number n and l, and this those angular part theta depends on l and m, while as the phi, it depends on magnetic quantum number. So overall, the wave function in case of hydrogen atom, the electron in the hydrogen atom, it is basically it has a radial part and the angular part. Whereas radial part gives us distance of electron from the nucleus, and the angular part, it gives us the concept of orbital, the shape of the orbital, or we should say the orientation of that wave function in the atom. So this is all about the basics of Schrodinger wave equation in case of hydrogen atom, and the concept of radial and angular wave functions. So in the next class now, we will try to see basically graphical representation of those wave functions, and that there's concept of nodes. So this is all about the basics of the radial and angular wave functions.